The types of problems we're going to be solving in this tutorial involves two log expressions and a number. The elimination of the logarithmic function will result in a linear equation or a rational equation. Don't forget there are practice problems at the end of this tutorial, so be sure to watch the entire thing and try the practice problems to demonstrate mastery of the contents of this presentation. Alright, to get us started, we're going to take a look at the steps that will be guiding our problem solving process. Okay, so we're taking a look at the steps for solving log equations. Steps for solving log equations. Alright, and then as indicated earlier, we're looking at equations that look like this. It has two log terms, two logs, and a number. Those are the type of problems that we're going to be working on. Okay, so here are the steps. There are 4 steps that we're going to employ to solve this log equations. Number 1, what you want to do is you want to collect log terms to one side. Collect log terms to one side, and you have the number on the other side, okay, with the number on the other side. So the key word here is collect. All right, collect log terms to one side. And then step number 2, you want to condense your log terms. Condense log terms into one. Here you're going to be making use of the product and quotient property of expone of logs. All right, so the key word here is condense. And then number 3, step 3, after condensing the logs into one, you're going to have one log on one side and a number on the other side. Now you're in the position to eliminate the log using exponents, because exponential functions are the inverse of logarithmic expression of a logarithmic function. So using the appropriate exponential approach, you will be able to eliminate the log term, okay, the log function. So the keyword here is eliminate. You want to eliminate that log component. And what will be resulting in this particular set of problems we're going to do, we're going to be ending up with a linear equation or a rational equation. So all you just simply do is you solve. All right, solve the resulting equation. In the next presentation that we're going to be doing is going to result in a quadratic equation. So look forward to that. All right, so these are the steps that we're going to be using to solve the log equations in this presentation. All right, let's take a look at some examples. So the instructions are as follows. You're to solve the given equations. So for question number 1, let's say we have the log equation, log base 2 of x plus 2 plus log base 2 of 3 equals 3. All right, so let's go ahead and solve this. We're going to be using the steps that we outlined earlier. So the acronym that you can keep in mind is CCES, collect, condense, eliminate, and solve. All right. So with this equation that we have, log base 2 of x plus 2 plus log base 2 of 3 equals 3. We're going to start by collecting log terms to one side and put the number on the other side, okay? So we'll take a look at what we have here. It's already collected nicely for us. You notice that the 2 log terms on the left side and the number is on the other side. Excellent. So we're done with the collection part. Now we're going to condense these 2 logs. Okay, So we have a sum of logs. Remember that the sum of logs is equivalent to the product of the logarithmic argument. So if you have log of x plus log of y, so you're having a sum of two logs in the regular world is the product of the logarithmic argument. So x times y. So in this particular situation, we have a plot here. So we're going to take a look at these two log arguments, and then we're going to be expressing them as a product, okay? So when we condense it, we're going to have log base 2 of 3 times x plus 2. Using this is the product property of logs right here that we're using, equal to 3. Okay, so we're going to go ahead and distribute this 3 across these two terms. So we have log base 2 of 3x plus 6. Okay, and then that's going to be equal to 3. So now we have condensed the log into 1. Now next step is the E step, eliminate. We're going to eliminate this log. Now this is a log base 2, so we're going to exponentiate both sides using 2 as the basis of exponentiation. Okay, so two big 2's and then a little log base 2 of 3x plus 6. All right, and then that's equal to 2 to a little 3. On the left side, the exponent and the logs are inverse operations. They take each other out. So we have 3x plus 6. And then 2 to the third power is 2 times 2 times 2, which is 8. Okay, so we've eliminated the logs. So now we're in the S step, which is just to solve for x. This is a two-step problem. Subtract 6 from both sides and divide by 3, and you get the final answer 2 over 3. Okay, so when you subtract 6 from both sides, you have 3x equals 2. Divide both sides by 3, x is equal to 2 over 3. And that's your answer. Now a side check that you need to do is to ensure that when you plug in this answer into both terms, it doesn't result in a negative input. So we have only one input here, which is x plus 2. When you plug in 2/3 into x plus 2, we see that we get 2/3 plus 2, the sum of two positive numbers, which is positive. So we know that it's a valid input. All right. When you substitute your answer into any of the variable components and you get a negative argument, it's outside the domain of the log function, which results in a no solution situation. All right. But this one works perfectly fine because we're not going to have a negative number when we plug in 2 over 3 into the x plus 2 spot. All right, let's move on to the next question. All right, let's take a look at question number 2. So for question 2, what if we have the situation where we are to solve the equation log of 400 is equal to log of x plus 2 plus 2. All right, let's solve this. So to solve this one right here, let's rewrite it. We're going to be following the same outline, CCES. Collect, condense, eliminate, and solve. All right, so let's collect first. You notice we have a log term on the left and a log term on the right. So what are we going to do here? How do we collect it? Do we move the log on the right to the left or the one on the left to the right? Remember, the goal is to isolate the number, right? So the number is on the right side. So if we move this log term to the left side, that will result in the isolation of the number and the collection of all the logs on the other side, namely the left side. Okay, if we move the log on the left to the right, then there'll be a number here that we have to move to the left. So that'll be 2 moves as opposed to just moving the log on the right to the left. Okay, so we're going to move the log on the right to the left just by simply subtracting log of x plus 2 from both sides of the equation. This is the collect step. So when we execute that move, we are going to have log of 400 minus log of x plus 2 equals 2. Okay, now we're done with the collection move because the logs are already collected to one side. We're now going to condense. So we have a difference here. So we're going to be using the quotient property. So we know log of x minus log of y. Subtraction of logs is the quotient in the real world, log of x over y. So let's apply that here. We're going to be looking at the quotient of 400 and the quantity x plus 2. So when we condense it, we have log of 400 divided by x plus 2. Okay, and that equals 2. Okay, so we've condensed the logs on the left side into 1. Now let's eliminate the log. So we're going to eliminate the log using the base. So this log right here does not have a specified base. So if the log doesn't have a base, okay, and it's not a natural log, it's a regular log, log, the default base is 10. All right, so there are two types of logs that do not have a base specified in them. The first one is just the regular log, let's say log of x. That one is log base 10. And the other is a natural log, and the natural log is basically log base e. Okay, so these are the two logs that have invisible bases. So the implied base of this is 10, and the implied base of this is e. All right, so let's go ahead and apply that idea here. So the implied base is 10. How does that help us? Well, we're going to eliminate. The eliminate move involves exponentiation. So we're going to put a big 10 on both sides. Exponentiate both sides. On the left side, we're going to have a little log base 10 of 400 over x plus 2. And then on the right side, a little 2. On the left side, the logs and the exponents are inverse functions, so they cancel each other out. So we have 400 over x plus 2 is equal to 10 squared, which is 100. Okay. Now, to solve this, put this over 1. We're just going to cross multiply. When we cross multiply, we'll have 400 equals 100 times x plus 2. Okay. And then on the left side, we'll distribute. The right side will distribute, right? So that's going to be 100x plus 200. Now we're going to subtract 200 from both sides of the equation. We want to get x isolated. So that will give us x equals, 100. Let's write it this way. 200 equals 100x. Divide both sides by 100 and you get your final answer, x equals 2. And that's your final answer. So just to check to make sure that we don't get an undefined expression, undefined term, when you plug into log of x plus 2, we have log of 4, so which is good because it's not a negative argument. All right, so this answer looks perfectly fine considering the domain of the log functions as just numbers that are bigger than 0. All right, let's take a look at the last question, problem number 3. Now, for this one, let's say we have the equation, the natural log of x equals the natural log of x plus 1 plus 2. All right, so let's go ahead and solve this log equation. So we have the natural log of x equals the natural log of x plus 1 plus 2. All right, so the first step is to collect. Okay, we want to collect the log terms to one side. So we're going to move ln of x plus 1 to the left. So we'll subtract ln of x plus 1 from both sides so that we have the isolation of the number on the right, and then the log terms are collected nicely on the left side. So we have ln x minus ln, or the natural log of x plus 1, equals 2. So this is the resulting situation when all the log terms are collected to one side, namely the left side. Okay, now we're going to go ahead and condense. We have a difference of logs here, so remember the quotient property for logs, so ln of x minus ln of y. In this situation, subtraction of logs is the quotient in the regular, well, ln of x over y. So in this particular case, we're going to have ln of the first logarithmic argument will be the numerator, and then the second will be the denominator expression. All right, so condense that into 1 equals 2. So we have it condensed. Now we're going to eliminate. Now, do you recall what is the base of a natural log function? The base is e. Okay, so there's an implied or invisible e right here. Bam. So what we're going to do is we're going to eliminate by exponentiation. So e is going to be our basis of exponentiation. So put a big E on the left side and a big E on the right side. And then on the left side, we have a little ln of x over x plus 1. Okay, and then on the right side, we have a little 2. So the base of ln is e, and the base of this exponential term is e also. So the inverses, they cancel each other out. We have x over x plus 1 equals e squared. Okay, so put this over 1. If we cross multiply, we'll have x equals e squared times x plus 1. So we'll distribute the e squared on the right side. So we have x e squared plus e squared. We're going to collect the terms with the x's to one side and then isolate the x, okay? So subtract x e squared from both sides. So when you subtract x e squared from both sides of the equation, we would have collected the terms with the x components in them. The variable terms, which is x minus x e squared equals e squared. Now we're going to factor out the like term from these two, which is x. So factor out an x. So we have 1 minus e squared equals e squared. And then the final step, just divide both sides by 1 minus e squared. All right, so I'm going to divide that. We're going to have, see, there you are, divided by 1 minus e squared. When we do that division, we're going to have x is equal to e squared divided by 1 minus e squared. A log function. So if you take a look at this number that we have right here, these two numbers are of the same magnitude, right? So if you have 1 minus e squared, it's gonna result in a negative number. Okay? So in this particular situation, you could plug it into your calculator to check it out. So this one is approximately, this number is approximately negative 1.156. You can plug in your calculator to check it out. So now you notice that this answer is a negative number. So when we plug it into both logarithmic arguments, we must have a positive input value, or else there's no solution. So when we plug in negative 1.156 into the first logarithmic term, is going to be negative. So that's a no-no. The arguments for log functions must be greater than 0. So based on that, so let me show you what I'm talking about right here. So if you wanted to do a check, you look at the natural log of negative 1.156. This is undefined. All right, so it's because you're violating the domain error. So as a result of this particular violation, you also have a violation here because negative 1.156 plus 1 will result in a negative argument too. So it takes just one to result in a domain violation. So in this particular problem, there are no solution. The only solution that we have is extraneous. So there's no solution here. All right, so there you have it. All right, so now it's time for you to try out some practice problems. So you want to pause and try these. Let's take a look at some practice problems that we promised to give to you. So the instructions is still to solve. So number one, let's say you have log base 8 of 4 minus log base 8 of x minus 4 equals log base 8 of 15. Number two, what if you have log base 6 of x plus 5 minus log base 6 of x is equal to 3? And then for number 3, let's say you have the natural log of x minus 5 plus the natural log of 5 equals 3. And then for number 4, the natural log of x minus the natural log of x minus 1 equals 2. All right, so go ahead and pause the video presentation at this time and try these 4 problems. When you're done, click on the playback button and we'll show you what the answers are. Alrighty, welcome back. Hopefully you had a chance to try out the practice problems. Here are the answers. Now, how well did you do? Let us know in the comment section below how well you did. If you have any questions, specify it in the comment section and we'll be more than glad to support you. Thanks so much for taking the time to watch this presentation. We appreciate all the support with your likes, comments, and shares. Don't forget to visit our website, Mathgotserved.com, for tons of support resources. Thanks again for watching. We'll see you in the next video. Goodbye.